Hi guys, so today we are going to do the question valid perfect square. Given a positive integer num, write a function which returns true if num is a perfect square, else false. Please do not use inbuilt functions such as square root. So what we have to do is we are given a number and we have to tell whether it is a perfect square of some other number. We can do it in a linear fashion, like we can start iterating from 1 up to the square up to a certain value, and then square each value and check if it is equal to the number or not. I'll write a pseudocode for this, but we'll discuss optimized approach after this. So I am basically telling, like, I'll take a variable I, then for int I is equal to 1, I is less than number, and I plus plus. If I into I is equal to num, then I'll return a true. Else this would return a true, and if at some point I into I becomes greater than num. So for example, if we have 17 as our input, so what will happen is, for 1 square will give us 1, then 2 square will give us 4, then 3 square will give us 9, and then 4 square will give us 16, and if then we calculate the 5 square, the 5 square would give us 25. So we see that for input 7, when num is equal to 17, then for the value 4, the square root is 16, and for the next value, the square now exceeds the given input. So we see that there is no integral value whose square is 17 equal to the nums. So basically I into I exceeds the given number, so at this point we return a false. So this is a linear approach, and to do this in logarithmic time we will use binary search. So how would we do it? Suppose the number is 16. So so it is obvious that the square root of this number would lie between 0 and 16. Why? Because it is quite obvious that for a given number the square root is always less than that number. Somewhere we do not know the exact position, but it is behind the number. So the search space becomes initially is start is equal to 0 and end is equal to the number itself, right? So this is our main observation, that the square root of the number lies behind the number from the start, that is 0, to the number itself. So like in case of binary search, what we do is split the search space into half. So basically we are doing start plus end divided by 2, so the value comes out to be 8. Okay, so then what we do is we check if the if we square this value, if we square the mid value, is it equal to the number? So is mid into mid equal to the number or not? So what we are doing is basically mid into mid is equal to n. So we'll check if 8 square is equal to 16. So it is not. So if mid into mid, if this value, let's call it v, if it is greater than n, so we basically need to reduce the search space. Because it is obvious that any number greater than 8 would give a square on being squared will give a value greater than the desired number. So we would make the search space smaller, and the end value would equal to mid minus 1 at this point. So mid minus 1, and start will remain at the initial position itself. So let me clear off the space. So at this point now what we have is, we have start at 0 and end at 7, because end was previously 8, so mid was 8, and 8 minus 1 is 7, so end would become at 7. So now we have this search space, and then we'll find the mid of these two values. That would come out 0 plus 7 divided by 2, that would give us value 3. 3 value is achieved, and we check if mid square is equal to the number, the input number. So 9 is less than 16. So basically we are doing mid into mid here is less than 16. So basically we cross out the search space, because any number less than 3 will give us a square less than the desired number. So now we have a search space which is from 3 to 7. Now we would now increase the start value, initialize the start value as mid plus 1. So now the search space would start from 4 to 7. So 4 to 7 will be our search space now. So 4 plus 7 divided by 2 would give us the mid value now. So 11 divided by 2 would give us value 5. So 5 is the new mid. So now we check 5 into 5 is less than 16 or greater than 16. So this comes out to be greater than 16. So now we see that that we have to cancel out this region, because any value here squared would give us value greater than 16. So now what we have is, we have search space from 4 to now we reduce because this was the mid value, so end now becomes mid minus 1. So we have just 4 in our search space now, and we check if 4 into 4 is equal to the nums value. So it is, so we return value 4 at the end. So we'll start coding, and side by side you will understand better. So what I am doing is, I'll take a start at 0 and at nums, and then I'll take a variable mid. I will not initialize it to any value. Then I'll start like we do a binary search. I'll do start is less than equal to end. So at this point we'll initialize mid is equal to start plus end divided by 2. Fine. And then we'll check if, see, we can do two things here. Mid into mid equal to nums. So if this is the case, then we'll return a true. But what happens is, like, this value will lead to an overflow of integers of the integer range. So what we would do here is, instead of multiplying, we can simply do this thing. We can divide it here by a float value of mid. See, what I am doing is, we were supposed to do 4 into 4 and compare it to 16. Instead of doing multiplication here, we could simply do 16 divided by 4, float of 4.0. So this would also give us value 4 here. So 4 equal to 4 will not lead to integer overflow, because here multiplication of larger numbers, here we are taking a smaller example, but for larger numbers it could lead to an integer overflow. So but this divide operation would always give us the correct range. So here also if this is the case, FLOAT, so if this is the case, we'll return true, else we'll check if mid is less than. So we are basically again calculating this value down here. So if this is the case, if that we have the mid into mid value less than the number, so in this case we'll do a start is equal to mid plus 1, else end is equal to mid minus 1 has to be done. So basically what I am doing is if mid into mid, like the square is less than the required number, so we are contracting the search space from the left hand side so that we search for bigger values, and else we are reducing it from the right hand side, and if we do not ever encounter a true here, so we'll return a false at the end. So I'll run the code for you. So this is giving a true answer. Also we'll have a case 17 where it should return a false. So for value 17 we get a false, and we'll check for a corner case that is 1. So in this case I think we'll get a runtime error. Okay, so we are compiling fine for this as well. So let's submit it. You guys need to check it for corner cases because the interviewer generally asks you for the corner cases, possible corner cases. With practice you will understand what the corner cases are, so we get a accepted answer in this case. And I hope you guys have understood it. Give a thumbs up if you understood it. Bye bye.